In this video, I'm going to go over some of the Chapter 3 topics. This is kind of like a review video for all of Chapter 3, so I would look at this after you look at the PowerPoints, after you look at some of the other videos and notes, and then come back to this if you still have questions. Because I'm kind of going to go through a little bit of everything that you see in Chapter 3. If you still have questions after this and all of the other notes, send me a email or a text or something with a question or pointing in a direction that you have the question. That way I can kind of make a video or put something up that will help you with specifically with what your question is. In Chapter 3, we're looking at logic, and logic is kind of one more step past all of the set work that you did in Chapter 2. A lot of it will look pretty similar, like you see with the symbols on the screen here. With the negation, in our other chapter, in Chapter 2, a negation was like a little apostrophe. Here, it's a tilde, and sometimes if you Google this stuff online, you'll see something that kind of looks like a little floaty L. They use that for a not as well. Conjunction, an and, was an upside down U before, and now it's got the point. The disjunction, or the or, was the regular U in the Chapter 2, and now it's the V. So you can see that they kind of look the same, that only in Chapter 3 it's a little pointier, where in Chapter 2 it had the nice curves. The new ones would be these conditionals, and the conditional is going to be very important, and the biconditional. Now, if there is not an arrow, then the order of your premies, the different statements that make up the compound statement, really is not going to matter. However, if it does have an arrow, like this conditional, you want to kind of think of it as a one-way street. You're going from whatever this first one is to whatever this second one is. And you are assuming that you have to go from one to the second statement. So from one to the two. You can't go from the two to the one. That'll be something different that we'll look at in a couple of minutes. The biconditional is kind of like a two-way street where the order doesn't really matter. So one way goes this, from 1 to 2 or 2 to 1. It's kind of the same thing. And what a biconditional really is a conditional, actually two conditionals, and an and stuck together. So it's kind of like a this way and then a this way, so that you can make a left or a right, so to say. So if I wanted to say I have a statement P, P is some statement, and we'll look at one, actually we'll look at two on the next screen, then not P would look like this. If Q was another statement, then P, this would be P and Q, this would be P or Q, this would be read if P, then Q, and then this would be read P if and only if Q. And so what I'm going to do is we're going to look at two statements, and we're going to piece together some sentences. So this is Abby. Abby is the younger of my two beagles. She is a handful, and when it is raining outside, then Abby is not outside. That is just how it works. So if my statement P is it is raining, and statement Q is Abby will go outside, I'm going to use these two premies to write these four statements. 1, 2, 3, 4. And you will most likely hear Abby barking at some point during this video. So it is raining is P. And then I have this connector in here that's an and, so that's my upside down V. But then over here with my Q statement, I have Abby will not go outside. You can see my Q is that Abby will go outside. And so if I want to flip the nots, like I have to put one in or I have to take one out, then I need a little tilde. So not Q. So this is the written form. In my sentence form, it is raining and Abby will not go outside. But in my statement form, it's P and not Q. If I have it is raining, which is P, or, so my V, and then I have Abby will go outside, which is Q. No nots needed, so it's just P or Q. This is my conditional. Wait, no. This is my conjunction, which I'm going to run out of room. This is a disjunction. Now we're going to look at our if-then, which is our conditional. And if it is not raining, well, if it is raining as P, I need to put this not in, so this is going to be a not P. If it is not raining, then, and so this if-then is going to set up my arrow. So I'm going from this first premise, which is if it is not raining, to then Abby will go outside. So Abby will go outside is Q. And so if it is not raining, then Abby will go outside. Looks like if not P, then this arrow, which means if then Q. Abby will go outside. Well, that's my first premise now, but my first premise is actually Q. There's no rule that P has to come first and Q has to come second. They can come in any order. Now, how you write them matters. Like you can't say, for this one, I'm going to make this P and this Q, and then in the next one, change it up if it's a part of the same pattern. So now this first one, Abby will go outside. Well, that's my Q statement, so that needs to come first this time. Then I have this if and only if, which is the double arrow street. So I have two arrows there. And Abby's only going outside if and only if it is not raining, which is not P. True statement. And so that's how we can use our written sentences to make these symbolic sentences, make it a little bit easier to kind of work with. Easier if you don't want to get clouded by what's going on in these sentences. So what a lot of times what we'll do is if you don't want to be swayed, if you will, by what the statement is saying, because when you hear the English form, you go, well, maybe this or maybe that. There's no maybes in math. There's true and false. And so what we'll do is we'll take some of these and we're going to set up some truth tables. Sometimes you can't tell if they kind of say the same thing. Like it kind of feels like these two say the same thing, right? Like P and not Q. If it is raining, Abby will not go outside. If it is raining, or Abby will go outside. It almost kind of sounds like they're saying the exact same thing. Well, with ands and ors, you can use something called De Morgan's Law, which you saw actually in the first one, in the first section that we looked at in chapter 2. Almost the exact same thing, right? Instead of A's and B's, we have P's and Q's. The way you would read this first one over here is that when you have the tilde floating around on the outside of the parentheses, you would say, it is false. So this sentence, if it is false if P or Q, would be it is false that it is raining or Abby will go outside. That would be the English version, right? The written version of what this one says right here in the blue. And I'm going to make it a little bit smaller so we can get it all on the same screen. Okay. That is this first statement right here. The equivalent statement, the statement that is truly saying the same thing and has the same truth value, is the flip of everything. It's almost like you're going to distribute this not. So if not P and not Q would be the logical equivalent. So let's look at this second one, and I will type that one in red. A logical equivalent would be it is not raining and Abby will not go outside. Those two say the same thing. It may not seem like it, but they do. And so when you don't want to get involved with, well, maybe it's this way, or maybe it's that way, or maybe you're talking about connotations, what you can do is take your statements, give them a letter, and then start using De Morgan's law or your truth tables to kind of see out what the different scenarios are. Now, truth tables really are all combinations of these 4 ways that we have to write sentences. There's really 4 rules. There's an and, there's an or, there's an if then, there's an if and only if. Oh, and there's Abby. Everything else is a combination of that. For an and to be considered true, so for this statement, it is raining and Abby will not go outside, to be considered a true compound statement, then all of the premises need to be true. So for ands to be true, both the statements need to be true. Otherwise, the whole thing is no good. So the best way to kind of describe this is if you have any kids at home and maybe your daughter says, Mom, I am going to go to Susie's and then I'm going to the mall. So I'm going to Susie's and I'm going to the mall. Well, if she doesn't go to Susie's or she doesn't go to the mall, if she doesn't do both, then she didn't technically tell you the truth. Right? So either you have to do both in order for the whole thing to be true, or something suspicious is going on. For an or, though, only one needs to be true. So, Mom, I'm either going to Susie's or I'm going to the mall. One of those things. So if she goes to the mall but didn't go to Susie's, she's not allowed. So ands, they both have to be true. And or, you only need one to be true. And it doesn't matter the order. So it could be true or true. It could be true or false. It could be false or true. All of these are true. The only way that she would be lying to you is she didn't do either one of those things. Similar to the and, but not completely, is the biconditional. And biconditionals, since math people are lazy, we usually shorten to say if, like with a double F, if and only if. That's what that biconditional means. To be true, both need to match, is what I'll say. So they either need to both be true to a true or false to a false. So true to true or false to false. Anything else is a lie. So this is true only if and only if this is true, and this is false if and only if this is false. So it's kind of like either it's a two-way street or it's not a two-way street. Either your cars are going to be able to go this way and this way, or they're not. You can't be a one-way street sometimes and a two-way street other times, unless, of course, you live in Charlotte and they make up their own traffic laws. Everywhere else in the world, you're either a two-way street or a one-way street. There's no back and forth. So this is how your overall statement would be considered true. The one that's a little weird is the one that we use the most, actually, and that's the if-then. The if-then actually is harder for it to be false than anything else. Then if-then is false only when a true leads to a false. That is the only time that statement is false. I can't tell you it assumes that you can't start off doing the right thing and accidentally do the wrong thing. So true to true is true. True to or false to false is true. False to true, oddly enough, is true. All of these make true statements. So I kind of think about this as the GPS. They're a little bit better now than when they first started. But if you've been using them for a while, or maybe Siri doesn't like you, sometimes Siri gets mad at me, you sometimes wonder what map it is that they're following. So let's say you put in the directions and you listen to them. Then you will get to where you're going. You may wonder why it's taking you such an odd way, but if you listen to the directions, it is true you were listening to directions, and it is true then you will get to where you're going. However, if you do not listen to the directions, you're not getting to where you're going. Most of the time, because it could happen that you don't listen to directions, but you still get to where you go. So like sometimes you're just like, whatever, Siri, I know where I'm going, so I'm just going to ignore you, and I'll still get there. So both false to true and false to false are both true. The only time it's false is this one, that you're listening to what it says, but then you don't get there. That's not going to happen. Or at least we'll assume that it doesn't happen. Usually, that is the case. I mean, it tells you where you're supposed to be going, and it gets you there. It doesn't usually happen to get you lost. So if we were going to set up a truth table, you would use these statements and kind of set up your boxes with any kind of combinations it is that you need over on this end. And then compare these statements using these rules. And in the other two videos that we had before, there was a bunch of examples of how to set up tables. So you can look through both of those. Some are a little bit shorter, some are a little bit longer, and you can look at how to set up those videos. I'm going to stop this one since we're already at 17 minutes, and then do another one for the last half.